Hello, this video is going to talk about how to convert between the different forms of quadratics. So for a quadratic, we do have three different forms. And when we say different forms, what we're really talking about is different ways that we can write a quadratic equation. They're all going to be equivalent to each other, but they're going to tell us different parts about the graph. So standard form is pretty much what you guys are used to seeing with quadratics. So this is like y equals x squared plus 6x plus 8. And you guys learned how to put this into factored form. Y equals x plus 4 and x plus 2. So we use the box and diamond for this one to get it into factored form. So you guys are already pretty much familiar with that. Now what we're going to learn about today is the graphing form. And remember, this is our vertex form, and it shows us the transformations that are happening. So our graphing form for this one would be y equals x plus 3 squared minus 1. And if you remember when I first started talking about this, like a couple of seconds ago, I told you that each of these different forms tells us a different part about the graph. And remember, we talked about this when we started talking about transformations of quadratics, that the vertex form tells us the vertex, which is why we call it vertex form. So our vertex for this one would be -3, -1. Remember, you go ahead and flip that h value when we pull it out, and then we keep the k value the same, so -3, -1. The factored form actually tells us our x-intercepts, and the way that we did that is we use the zero product property, so these would be -4, 0 and -2, 0. And then standard form actually shows us the y-intercept. And the y-intercept is going to be 0, 8. It's always going to be this last number right here, because the way that we find a y-intercept is to plug in 0 for x, and if we plug in 0 for all the x's, then we'll just be left with 8. So each of these forms have their specific reasons of why we want them, because they tell us different parts of the equation and a different part of the quadratic. So we already know how to go from standard to factored form, and what we're going to learn how to do today is to go between standard and graphing form. So let's go ahead and take a look at some of these examples. So here is an example of an equation that is written in vertex form. So we know that our vertex is -3, -2. So what we want to be able to do is to put this into standard form. And remember, standard form is that y equals ax squared plus bx plus c, like the normal format that we're used to seeing quadratics in. So what we're going to do in order to work with this problem and convert it to standard form is we're going to utilize order of operations. So we're going to use PEMDAS. Please excuse my dear Aunt Sally. So the first thing that we want to do is we want to deal with parentheses. So x plus 3. There's nothing that we can simplify in the parentheses. So what we want to do is move on to exponents. And we see that we have this squared. So when we have something that's squared, what that's asking us to do is to write it out 2 times. So x plus 3 times x plus 3. So now we don't have any more exponents. What we need to do is our multiplication. And I'm actually going to multiply this x plus 3 times x plus 3 first. And if you remember back to Algebra 1, we used a box in order to be able to do this. And we put x and 3 and x and 3 on both sides. So we got x squared, 3x, 3x, and 9. And when we simplify this, we got x squared plus 3x plus 3x plus 9. And that was x squared plus 6x plus 9. So what I'm going to do is I'm going to replace the x plus 3's, the two of them, with this x squared plus 6x plus 9. So I get 2, and I'm still multiplying x plus x squared plus 6x plus 9 minus 2. So I still have multiplication going on here. I need to distribute my 2 to the x squared, to the 6, and to the 9. So I get 2x squared plus 12x plus 18 minus 2 at the end. And then my last part is going to be to simplify the like terms at the end. So I get 2x squared plus 12x plus 16. And this is my final answer in standard form. You don't have to do any simplifying like taking out a GCF or anything like that. You just want to leave your answer in that format because that is standard form. And if you remember that standard form tells us the y-intercept. So for this one it's going to be 0, 16. So those go together. So we went from vertex form to standard form using order of operations. Now let's go ahead and go from standard form to vertex form. So this is our standard form right here. Remember, standard form tells us our y-intercept. So in this case, it's going to be 0, 15. So when we go to vertex form, remember we wanted to take the format of y equals some a value, parentheses x, some h value, so this is our a, our h, and then some k value. So it always kind of takes this format. So what we're going to do in order to find each of these parts is that you are going to look at this first part of the equation right here. This right here is technically our a value, and since there's no number there, it's technically 1. So our a value is 1. So you look in front of the x squared to find your a value. Now, in order to find your h value, what you're going to do is you're going to divide the middle term by 2. So positive 8 divided by 2 is positive 4. And then what we're going to do is we're going to take that 4 and we're going to square it. So we get 16. And I'm going to write that underneath my 15, and I'm going to subtract those two numbers. So 15 minus 16, that gives me minus 1. So my a value came from in front of the x squared. My h value was the middle term divided by 2. That was 4. I squared that, that's how I got 16, and I subtracted the 16 from the 15 and got negative 1. So that means that our vertex is negative 4, comma, negative 1, because remember we do flip that h value. So let's go ahead and take a look at one more of these because I think this is our newest kind of converting. So again, this is in standard form, so it tells us our y-intercept. So our y-intercept is going to be 0, 16, because again, it's that last number. So we want to convert this to vertex forms. We have y equals a x h squared, and then our k value. So this is our a, our k, oops, not our k. This is our h, and then this is our k. So remember, we look to the front of the equation right here to see our a value. Since there's no number there, we have to assume that it's 1, so we're going to put a 1 right there. We are going to divide this middle term by 2. So negative 10 divided by 2 is negative 5. That gives us our number right there. And then negative 5 squared is 25, so I'm going to write that underneath here, and I'm going to subtract them. So 16 minus 25 gives me negative 9. So this is my vertex form right here, y equals 1, x minus 5 squared minus 9, which means that my vertex is 5, because we switched the sign of the h, comma negative 9. Thank you so much for watching.